Today we're going to talk about inequalities. Now, an inequality is just a number statement that compares two different expressions. For example, you can say 2 plus 3 is less than 4 plus 9. Two expressions, and there's our less than sign. What are some other inequality signs? Well, we have greater than, we have less than or equal to, and greater than or equal to. And we're going to use all four of those today. Here are three statements that we're going to change into inequalities. The first one says all real numbers x less than or equal to -7. And what they're saying here is that they're using the letter x to represent all real numbers. And so what I suggest doing is to actually underline the inequality statement, less than or equal to. Well, x is on one side, less than or equal to, and then on the other side, the -7. Next one, 6 less than a number k is greater than 13. Again, I'm going to underline my inequality statement, is greater than. And then on the right-hand side is going to be 13. What are we going to do with this? Well, do you guys see the word than? That means flip-flop. And so we're actually going to say k minus 6 is greater than 13. The last one, the sum of t and 7 is less than -3. Well, less than, and here's my -3. And the sum of t and 7 is just t plus 7. Identifying solutions by evaluating. Now this statement is in your book, but I'm going to read it to you. A solution of an inequality is any number that makes the inequality true. The solutions of the inequality x is less than 5 are all real numbers x that are less than 5. You can evaluate an expression to determine whether a value is a solution of an inequality. So if you look at the first one here, it says, is the number a solution of 2x plus 1 is greater than -3? And they give you this -3. So all you do is just put it in. 2x plus 1 is greater than -3. So is, whoops, that's not right. Undo. 2 times -3 plus 1, is that greater than -3? Well, -6 plus 1, is that greater than -3? Yeah, no. That is not. So look at the next one. 2x plus 1 greater than -3, except this time we want to use -1. So 2 times -1 plus 1, is that greater than -3? Well, 2 times -1 is -2, plus 1 is -1. Is -1 less than, or I'm sorry, greater than -3? Yes. Pretty simple. So basically you just take the number they give you, put it into the inequality, and see if it's equal. Now I'm going to remind you on how to graph inequalities. We'll start with x is less than 4. It means all real numbers less than 4. 4 is my target number, but can x equal 4? No. So I'm going to put an open circle around the 4. This basically says this is where I'm starting, but it can't equal 4. And then I'm going to do all real numbers. I'm going to shade in all real numbers less than 4, which is this direction, right here. Next one, x is greater than 4. All right, same sort of thing. 4 is my target number, but x cannot equal 4, so I'm going to put an open circle there. And then I'm going to shade in all the numbers that are greater than 4, which is this direction. X is less than or equal to 4. 4 is my target number, but this time, can x equal 4? Yes. So I'm going to shade it in, because that way I can say that it also is 4, and then I'm going to shade everything that is less than 4. Now, x is greater than or equal to 4 is exactly the same way. You shade in the 4, and it's a closed dot, and you go, if it's greater than, you go towards the 8. But one girl in my second period class brought up this. Hey, Mrs. Knar, the arrow goes the direction that the inequality sign is pointing. And I'm like, no, 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 don't do that, because once in a while you're going to get something that looks like this. 10 is greater than or equal to x. Alrighty, what's my target number? 10, which means that, you know what? Well, this is funny. I don't have a 10 on my number line, and my program won't let me delete it. So I'm going to get a little sloppy, sorry. We're just going to say 8. Just get rid of this. And we say 8 is greater than or equal to x. So 8 is my target, and here's the deal. Do I fill it in? Well, yeah, because of the equal sign. Now, my suggestion to you is not let's draw the arrow the same direction as the inequality, but read from the x to the number. And if you do that, it says x is less than or equal to 8. Well, what numbers on the number line are less than or equal to 8? These. So here's a case where your arrow is going the opposite direction as your inequality sign. So be careful when you look at those. Next, we're going to write an inequality from a graph. And this is actually pretty simple. What you do is you put down your letter, and I'm just going to keep using x, and you put down your target number. In this case, it's a -1. And then you look at the shaded line and say, all right, is x going to be greater than or less than -1? Is the shaded line greater than or less than -1? In this case, it's greater than. However, it's a closed dot on the -1, so it's also equal to. Now, this one just happens to be the exact same one, so we're going to skip that. Go to the bottom one. I'm going to put the x, and our target number is a 4. Now, this time the shaded line is what? Less than or greater than 4? Well, it's less than. Is it less than or equal to? Nope, because there's an open dot there on the 4. Now I want you to take some time to do these two on your own. What'd you get for A? Well, hopefully you got x, and you put a -3, and see that the red line there goes less than -3. And in B, you have the x, and you have a 0, and you see that the line is greater than, but we also have a closed dot, so greater than or equal to 0. The last piece of the lesson here is writing an inequality based on a picture or a word phrase. And on your homework, it'll be a word phrase and won't be a picture. And so the first thing we want to do is define the variable. Well, your variable is almost always the label to your number. So if you look at the first one, trail rides starting at $19.99. Well, what's the label of $19.99? Dollars. All right, so let's see equal the cost of a trail ride. And so I'll put C, and I'll have $19.99. Now, if you guys look at that, starting at $19.99, can it equal $19.99? Absolutely. Can they be less than $19.99? Well, not if it starts at it. They're probably going to be more than. So we say C is greater than or equal to $19.99. And you look at the next one, letter B, 8 miles per hour. I know it's kind of slow, but what is my label going to be? Miles per hour. So defining my variable, let S equal the legal speed in miles per hour. Notice it say legal, so you can't go higher than 8 miles per hour. We'll say S here, 8. And we'll say it is either going to be less than or equal to 8. For this last problem, let's talk a little bit about common sense. You see here that the answer is exactly what we just said. S is less than or equal to 8. So can the speed be all real numbers less than or equal to 8? How many of you say yes? How many of you say no? Well, the answer is no, because all real numbers include your negative numbers, and as far as I can tell, you can't go -6 miles per hour.